Welcome to this mock system design interview. My name is Mark. I'm a former engineering manager, most of my time at Google, some time in other companies. Our candidate today is Shivali Maheshwari. She is a senior software engineer at Amazon, has been there 7 years. Shivali, welcome and thank you for doing this with us. Tell us a little bit about yourself.
Oh, thanks. Thank you. Thanks a lot, Mark, for giving me this opportunity. So I have been with Amazon for the last 7 years and have gotten chance to work across various systems, varying from infrastructure to building systems from scratch, various platform systems. Apart from it, I also like doing interviewing. So I have done close to 1,000 interviews, and so now I'm on the other side, and going to have an experience like a candidate. So it's really good. Yeah.
Good. Well, it's good to have you here. So I'm going to ask you to design LinkedIn. Now, of course, that's pretty big picture.
Yeah. Great. Okay, so is it okay if I just make some notes on this drawing window itself?
Yeah, absolutely. That would be great. Help me follow your thinking too.
Great. So we're thinking about designing a LinkedIn system. So let's see. So LinkedIn actually is pretty huge. It has a lot of features. Couple of features are something starts from job postings, employers creating the job postings, users looking for the jobs, applying for the jobs. Then it also has plenty of other features in terms of similar to how the social network sites have, in terms of you can post things over there, you can do various interactions with your post, comments, likes, etc. And and then it also has job recommendations. Mm-hmm. And it has chat messaging. So it's pretty big, right? So shall we focus on certain areas? And what do you think?
Yeah, that's a good idea. I mean, it is big. It is and we're hard to design an entire system in 45 minutes that covers everything. So Good point. You mentioned jobs. Sounds like jobs is kind of, as we would expect, as the core feature of LinkedIn. So let's focus on job seekers for purposes of this design. And why don't we focus on the functionality of a job seeker to find a job? So I'm looking for product manager roles, or I'm looking for a test engineering role, or whatever it might be. That might be, let's assume that that's the use case that we're interested in.
Okay. I understand that now.
Right after you get the system design question from the interviewer, you need to set the stage. Shivali did a great job of doing this by sharing her approach, including that she'll be taking notes, as well as summarizing some of the larger features of the application that the system design might be a part of.
Great. So, let me try to list down some of the requirements that we are looking for. I'm calling them functional requirements. So one is as an employer, they would be creating the jobs, so adding those job postings in LinkedIn. Mm-hmm. And as a user of a LinkedIn, I should be able to search jobs. And as a user, first I register myself. I'll also write I should be able to first create my profile on LinkedIn and then search the jobs on LinkedIn. Then also, in addition to that, user can also get recommendations, a part of the job posting itself. Shall we include that as a requirement? What do you think about it? Or
yeah, good question. So you're actually helping me refine the scope of this design as we're talking about this. Let's do this. You mentioned the profile. So with the profile, the LinkedIn profile, let's assume that I, as a job seeker, have filled out my profile. I've got my entire career history there. I've got maybe I'm even sharing salary information, possibly where it's allowed or not. But I'm sharing my bio, I'm sharing what I'm interested in, my skills. I have you LinkedIn have my profile pretty well fleshed out. And so I would like to, with a current focus on AI, let's focus on me finding a job. I want to search for a job, and I would only want to give you let's look at it from a back end perspective again, just to try to limit the scope. I don't really want to get into the front end side of things here. So from a back end perspective, maybe there's an API that gets called where it says, find me a job for me, the job seeker, for a particular role and whatever that role might be. And why not? I'd be interested in hearing how you incorporate AI into this, so that you mentioned job recommendations, so that I get really relevant recommendations using AI, and you've got my entire profile again available. So maybe I'm giving you too much scope here, but talk to me about that. How does that sound to you?
Yeah, I think that's a very close and a relevant use case as well in terms of the search. And of course, I want as a user to be shown the relevant results. So that totally makes sense. I think it's better that we include it. So essentially, we want a relevance angle as well in terms of the job recommendations. And also, like AI is one part of it. If we can utilize our current technologies to make it more powerful.
Yeah.
Okay.
And I think we're okay leaving out the employer side of things for purposes of this design. I think it's a good point that you're, to include that from a functionality perspective. But for this system design, let's focus on the job seeker side of things. One of the first steps in a system design interview is identifying functional requirements. And this includes typically scoping the problem to something that you can accomplish in the space of an interview. Shivali did a really nice job of this, talking about the different aspects of LinkedIn and what you might do in terms of the use cases. And she also referenced modern technology, in this case, AI. You can do that if that's appropriate.
Okay, great. Now, just thinking in terms of the non-functional requirements, I want one thing is, as soon as the user searches for it, the results should be quick, so that don't have to wait. So I'm what I mean by this is probably I'm thinking it has to be a low latency API since we are scoping it to backend. So maybe something returning results within maybe 200 milliseconds, so that overall the user perceived end-to-end latency is less than 1 second.
Okay.
What do
so
you think?
200 milliseconds, are you referring to sort of the backend API side of things?
Yeah, correct.
Okay.
Does it sound a reasonable assumption?
Sounds good to me.
Okay. The other thing that I also want to consider is, of course, the availability of the system and the fault tolerance part. So that is definitely the case. And the third thing that I want to think about is the as in my system. Sorry, I think I think I'm bad with the spelling, so I'll just keep it to fault tolerance. And then the last thing that I want to say is about the consistency part. So I think in this case, probably I don't want it to be strongly consistent. I'm okay with eventually consistent systems. I mean, for example, if the recent job posting is also not appearing in my result, it's still fine. Maybe in the very next set of results, it will be there. Yeah,
that sounds fine. Non-functional requirements include performance and availability and the usual distributed systems topics. Shivali did a nice job of pointing out the differences between backend and user latencies in this case. She also did a nice job explaining her choice of eventual consistency.
So we discussed at a high level about requirements. Let's now think about a bit of in terms of the scale. What kind of a system I would like to have. So if I mean LinkedIn is pretty big, right? So assuming they have it's probably more than this, but let me try to make an assumption of 100 million daily active users that LinkedIn has, and then as we discussed that mostly people actually use LinkedIn for seeking jobs. So like I can make a fair assumption that maybe every in a day, like outside 40% or 30% of these users are actually coming for searching jobs.
Sure.
What do you think? Okay,
sounds good.
That
sounds
good.
Yeah.
Fine.
That sounds great.
So maybe I'll take a number of 40% to have some buffer in the system. So 40% of the people, so which is equivalent to 40 million in this case, are my daily active users who are actually searching for jobs. So my job API, which is like search job API, which I'll be creating, will roughly have a scale of like so 40 million requests in a day, and definitely there is going to be a peak time during the daytime and a less request during the nighttime. So that may I think roughly would come to let me just think. Maybe I think I can make a fair assumption of around maybe 5,000 TPS. Yeah, so I think I'll make an assumption of maybe like they do on an average of 3 to 4 searches a day.
Okay.
Is that fair?
Okay.
Yeah.
Okay. So then,
I mean, there, definitely there will be some users who are more actively seeking than others, so they'll definitely be doing more. But on an average, I think I'll take an assumption of maybe 4 searches. So with that, I think our peak TPS, actually, I have to revise this number. I think I can maybe take some something around so multiplying it by 4, like 20,000 TPS.
can you just walk me through that math?
Yeah, so it's like so 40 million users right now. If I try to spread it across the day, I think it will come to roughly some 600 or TPS, which will be like per user kind of a TPS. The TPS spread across total number of searches per second. But then if I say that user would also, and we have to think of a peak around it. So if it's like, let's say 600, 700, I'm assuming like the peak will be sometime around a particular hours, which may be around like 7 or 8 times than that number. So I've taken a rough estimate of it around 5,000 TPS. And then if we are saying that it can be more searches, so hence multiplying it by that number.
Okay.
So this comes around 2,000 TPS if I roughly divide it by average. And I have taken, I think, multiply by 10 factor, which is
I see. Gotcha.
Peak TPS.
Okay. I see. Okay.
So we discussed about scale. Actually, in terms of scale, another thing that we also, this is about users. The another thing that we also need to think about is the jobs. Because eventually the finding jobs need to search from that jobs data store.
Okay.
So let's think about jobs, right? So, so we are interested in about active jobs because the ones which are open are the ones people will be finding from. So, I mean, I think given the organization and given the scale of LinkedIn, so I'm making an assumption of maybe 10 million jobs. Is that fine, or it's generally more?
That sounds fine. So you're saying 10 million sort of active jobs in the system.
Yeah, across different job families everywhere.
That sounds okay to me. Before you start designing your system, it's a good idea to get a sense of scale. How big is this thing going to be? Shivali did a really nice job of looking at scale for both traffic and data and mapping the daily active users and traffic for a day down to an instantaneous rate, including looking at peak traffic times. She also did a nice job explaining her math. My preference is to write down the math, but as long as the interviewer can follow what you're doing, that's the most important part.
Okay, sounds fine. Okay.
Yeah.
Great. So we have done a rough estimation of scale now. Now let's moving on to the, shall I now move on to the APIs maybe?
Oh yeah, that's good point. We are talking about APIs. Let's do that. Yeah.
Okay, so the API, so it's like a search API that I want to create. So search jobs, right? And so it's going to be a GET API. Let's see. Okay, so search jobs, and then I want in terms of my input parameter, right? So there can be definitely, I think you brought in a very good point that I do have everything about the user, right? And I can just provide them the recommendations according to it. Or the other thing is, even if the user wants to do some filtration, like for example, today they are in a different job family, they want to search for a different job family. In such cases, the user can maybe tell me that what kind of things they are looking for, or if they are today in a certain location and now they are thinking of jobs maybe internationally or remote jobs or any different kind of jobs, they can look for those by providing those to me as the request parameters. So, some things like maybe location or maybe their a certain job roles. So such things can be provided to me in the params, and then my output would be some just list of jobs, and and then also of course some status code and details in terms of the response, right? And also these jobs, I mean, I'm just trying to create a jobs list, which is like each job will have certain parameters. Is my screen visible? I'm just trying to see. I'm not moving too down. Okay. So essentially, for example, these jobs could be something like having job ID and some parameters like which is the organization, and then maybe the job role, the experience someone they are looking for, and things like that. And of course, the skill set. So this way we can have different parameters of a job sent, and we can have multiple jobs being sent. Another thing is, in order to limit the jobs, and I think I also mentioned about a status code below. I'll just put it here. So the status code. The another thing I want to call out is since it's going, I mean, just to limit our results, and I mean some job roles could be very famous than other job roles, and they may return like a lot of relevant jobs. So just to limit such things, we can also implement pagination in our APIs to make sure that we are sending the relevant results, and also they are able to move forward, right? And apart from the basic things, like I just want to call out, for example, in terms of the exception handling, validation in terms of the parameters, request parameters, and also of course the authentication thing. We keep those things in mind while implementing the API.
Yeah. So tell me about that just a little bit. So let's assume, for purposes of this, that the application that I'm wanting to build on top of your search API, which is a backend. Let's assume that we're behind the I don't want to say same walled garden, but that there's some level of trust here between me and your system. However, I still need to somehow identify myself as a user, or the user needs to be identified in some way. At a high level, how do you typically do that, or how would you do that?
Yeah, so correct. So essentially, my when they're calling my APIs, right? So I need to have that authentication performed. So it can be basis like a token that is coming to me in the request, or it can be basis some identifier which can be like client ID, etc., things like that. So that way we can also like do other set of authorizations that if required. And that is also relevant if we when we have to put in like some throttling limits to avoid like requests from a lot of bad users, and just to keep the system in the like safe from any kind of threat issues. Yeah.
Gotcha. Okay, good point. Even if an API seems really simple, it's a good idea to just write down what it looks like semantically. This doesn't need to be perfect syntax. Shivali did a really nice job of calling this out, including adding some information about possible pagination. She also did a good job mentioning authentication authorization as a potential way to not only protect against attacks, but also to provide rate limiting in case that's needed. So you're talking about preventing against denial of service attacks, sort of that sort of thing. Okay, gotcha. Okay. Great.
So we discussed about API. So shall I now move to a high level system design for it?
Yeah,
or
sounds
anything else? Okay.
That sounds great. Let's dive in.
Okay, now let's move on to the high-level design. So let's say we have a API gateway, which is which is actually responsible for load balancing, and also at the same time it will be doing the rate limiting as well for me. So for now, I'm just going to start with a very basic design, which helps us just fulfill the use case, and I'll try to optimize and the design as we go forward. Yeah.
Okay.
So if we have an API gateway, let's say we have a search service, which is responsible for search jobs service, which is responsible for helping me search jobs for a user. Let me put it here. Now, let's say, so the search jobs definitely, there is another service that is there in the picture, right, which is actually given to the employers, will be responsible for inserting the job. For now, I just add it so that it becomes clear. So it's like maybe a job manager kind of a service, which is responsible for adding the jobs which the employers are adding in my jobs data store. Because we'll be utilizing this functionality for our search jobs service. And in addition, I am also having, let's say, the user profile database. So I'm just creating here the users DB as well. This is like user profile DB rather. Users profile database. So yeah. So we are having these two data stores with us. One is responsible for storing the jobs, another is storing for storing the jobs profile. Now, how my search service jobs is doing. So since we have to return it in a very low latency, what also matters to us is like how efficiently can we search the jobs. So I'm thinking to break this into two things, right? First, I need to find out relevant jobs for the user. And then the second thing is like relevant, or rather I would say first I need to find the applicable jobs for the user, which maybe basis their filters that they have added, or it could be also basis their profile. Once I have those applicable jobs with me, what I also need to make sure is the order in which they are returned are also something which is like the top jobs are at are like at the top for the user, so that they can find the most relevant things. So I'm trying to break this into two pieces. One is finding the applicable jobs, and second is ranking them. So hence, so in order to now focusing on the first part, which is finding the applicable jobs, there the thing is like I should be able to search basis the geolocation, the location that we talked about, which is like maybe the country or the state that they're looking for, and the other thing is the job role that they're looking for, and also sometimes the organization, particular organization they're thinking of. So hence what I'm also thinking is like we should have another data store, another data store, which is like my job my key job data is stored here. So the difference between these two is like this is the jobs data store, which is primarily for the key CRUD operations. Like when someone is the employer is posting a job, I'll also draw the arrows so that it's clear how I'm thinking about the flow. So essentially, as soon as they are doing the creating the jobs or updating the jobs or deleting the jobs, everything is going into the jobs data store. From there, I'm syncing this data to my jobs data, another data store. And so that this one could be a very simple data store, since it has to store like a 20 million jobs, but I'm not going to use this data store for search, but it's primarily for maintaining the entire details of what happened when. So I can, but since jobs will have a lot of data, which is like a lot of other fields and which could be relevant for some, not for there. So it's very unstructured form of a data. And also I need it to be scalable. So I would keep some NoSQL data store for this case. And this, so I probably would like to use some managed data store so that we don't have to hassle about like scaling, descaling, things like that. So probably like Amazon DynamoDB kind of a data store. While this data store, the other data where I'm seeking jobs, here we'll be putting on those key fields where we want the search to happen, and primarily like the fields like location, the job role, etc. So only that set of data will go into this data store, which will help us figure out the relevant job IDs. And this data store can be something which is very efficient for searching and also on the multiple fields. So data store like Elasticsearch, again, fully managed service, and you can index a lot of data over there. So yeah, so something like this is what I'm thinking. So for our 20 million jobs, and this search job service will actually query the data from this Elasticsearch to figure out first the applicable jobs. Okay. The another thing we also discussed about is, for example, two scenarios when it has the data already being passed into the filters, and the other case when it doesn't have the data. So in that case, basis the user ID, I'll call this user profile database to fetch us the relevant things and then information, and then make that query.
Once you get to the high-level design, it's really important that the interviewer can follow your thinking. This is why a drawing tool is essential. It's not important that everything looks perfect. You just need to have the basic components and concepts so that the interviewer can see what you're thinking. Shivali did a really nice job of sharing her approach and her thinking along the way, including identifying the purpose and the type of data stores that she might use as part of her components. She also did a nice job describing the rationale for some of the technology choices. This is really important.
Okay, so how does it feel? Like any questions or?
Yeah, so can you I'm just trying to make sure I clearly understand the difference between the jobs data store and the job data. Can you maybe just re-clarify that for me?
So okay, so this is more like the all the job related information which is being added as soon as the job is created. So this will have like all the details when it got created, what is the job status currently, is it active, not active, or it got closed, and something whenever any update happens, whenever any delete happens, right? Now this job data Elasticsearch, as soon as a job gets created and it's in the active position, it will get sent to this Elasticsearch. And similarly, when the jobs are expired or gets deleted, it will also get deleted from this Elasticsearch. But in this, we are not storing the entire job details. Like, for example, job will have a lot of other details as well, right? Like, for example, the things which are even not, like, for example, how to, the apply link for a job, right? Or the things which are not relevant in terms of the search, but then are the metadata for related to the job, like, for example. So for example, the apply link, or for example, how it should look like, or some image related data, right? Etc. So, but everything related to it is stored in this, but in this Elasticsearch, we are only storing the fields which are searchable or which are like tags. I mean, one way of saying it is like, can refer to as tags for that, right? So we are tagging like this job ID is in this location and is for this job role and also for maybe for this organization. Let's assume these are the only 3 fields for now where the search can happen. So all that data is indexed in this Elasticsearch and alongside a job ID. So whenever someone is searching for a job, so I'll search from it to get the faster results and then maybe decorate it with more database so that more data from my job data store to show it back to the user.
Okay, so let me see if I can rephrase this because to reflect this back to you to make sure I'm really getting what you're saying. So that the job database at the top that the employers are basically uploading into, that's sort of all the data for any kind of job, whether it's active or not, and it contains everything. It's got the apply links, it's got images, it's got metadata, whatever stuff that is. The bottom one is your sort of active jobs metadata search database or something like that. Is that, and you don't have to rename it. I'm just trying to make sure I understand what you're saying, but that's only active jobs and that's only the stuff that's relevant, like you said, for searches. Okay, that makes sense. Thank you. That's very helpful. I think I understand now the distinction. So, okay. So your search job service is going to, when I do a search, if the application on my behalf as a job seeker is doing a search, is essentially looking up my profile in the user profile database, and it's taking the parameters, those filter parameters or request parameters that I specify or were specified in the API. And with a combination of those is then searching this active jobs database. Is that correct?
Yeah, correct. Okay. So that's what I'm thinking. And due to this also the scale of these two, right? Like this will have very high scale in terms of reads.
Sure.
Because of course my search jobs API would be calling that. So, and however, this will be very less because the employers are doing those actions, right?
Sure. Fair enough. In order to be really clear about your choice of data stores, it's a good idea to use examples like Shivali did to go deeper. It's also useful to touch on scale because that may influence your choices.
So, okay. So now focusing back on this. So, we have found out our relevant jobs from the Elasticsearch. The next thing we want to do is rank these jobs, right? So maybe I'm let's take a very simplified version of my ranking service. So this service, So this service is actually responsible for whatever are my search results. I'll send them to my, let me just use this arrow rather. I'll search them, I'll send it to my ranking service, which will actually rank these jobs and then return the result back. Now, when it comes to ranking, right, like there are different things that we can do around here. So one, there are very simple ways of ranking these, which is like same for all the users, like maybe by the posted date or maybe by the jobs which are hit very frequently, things like that. By hits, I mean like there are a lot of clicks on those jobs. So things like that. Like we can bring the user personalization angle also into the picture. So like let's say there is a personalization service which can be backed by large language models or Gen AI. So this personalization will actually, so we have figured out the relevant job spaces. Like first we have done is for example, if you are today a software engineer, I figured out the relevant software engineer job roles basis your experience from my active job data search, right? Now I want to rank them so that whatever is the most relevant to you comes at the top. So in order to do so, what I'm doing is I'm trying to bring in this personalization angle user, and this will be integrated with the ranking service. What this another thing is doing, right? For example, basis what my past searches, my past clicks, my past views, etc., and my interactions, everything capturing that engagement. It's also showing that apart from though I'm working today in this job role, I may be interested in these things, or I'm even from the active jobs that you have filtered out, right? Maybe this is the most active or most relevant thing for me. Let's start from the ranking service, right? So the ranking service will actually rank all the jobs which my active job data store has given me. So now in order to do that ranking, so there could be some ways of like doing the ranking basis, maybe simple logic as like the job posting date, but also that can be further enhanced by bringing in the personalization angle, where we are not doing just the generic way of ranking for every user, but we are also considering their activities, how they are doing, for example, how they have been interacting on LinkedIn. So we will also utilize that data, which is like, let's say, let me say thing like job activities, right? So basis the job postings or let's say the job posting activities or the job activities, anything. So all the activities that they are doing, so all that data will also go into the personalization service, and personalization service can also maybe learn a lot more from a user angle, the user profile angle. And in addition, they can also take in the feedback. For example, if user, let's say, has applied for a posting for that organization before, it's a very strong recommendation, strong signal that they are very interested in it, versus what if they have just viewed that and have not done any action, right? So all those things are signals to the personalization service, and there, because we have so much of data, we can actually build, like, use Gen AI and build large language model, and our ranking service can then utilize this information to rank the jobs for a user. So then the personalization is actually giving me that this is how, for example, for every the jobs that I've figured out, right, from my active job data store, it's actually doing giving me maybe a score, like large language models only does, right? So score for each of them, that, and basis that I'm actually ranking them, that this job is more relevant to the user versus this is less relevant. So using that, I'm actually ranking my jobs. Service is first calling this data store to figure out the active jobs, and then it's making a call to the ranking service, and eventually it will return back this result by decorating it with the metadata, for example, the apply links, etc., by querying again from the my jobs NoSQL database, like just to fetch this data. It will interact with this as well, and eventually it will return. So it's like first is this call, second is this ranking service call, and third is the metadata call.
How would you utilize or integrate your search job service with, say, an enterprise version of OpenAI or something like that? That in order to make this.
Okay. That's a very interesting problem, and So given, I think yes, the things will get a lot of more simplified if we just think about how the technology will evolve during that time. So it would be something like, let's say I have an OpenAI which has like a lot of information. In terms of the job history, the job activities, the all the active jobs, everything is there in that one single system. And let's say it also gives me some prompt or some text. Let's say some console where I can just put in some information or some prompt. I can just give it a prompt in very maybe in an English like sentence, and I can just whatever user is trying to search, right? I can just feed in those keywords and it's doing everything. So that could be very simple. Like I have a search job service, which is then taking in the input, like what I want to search. It may be like if it has already from a user, or it's querying the user profiles database, and then just converting it into a query, or maybe which is like of certain keywords, and then calling that OpenAI layer, which is saying like, find me the relevant jobs for this user who is in maybe this location, right? Who is searching for the jobs in this location. So I'll give us very simple text like that. So that way, everything is, all that I've drawn is now under the hood, like AI is managing and my large language models are managing that. Yeah.
Okay. How would you set up like an enterprise version of OpenAI to be able to access all of this LinkedIn data? So let's say we're LinkedIn and we're licensing, an instance of OpenAI, but we don't want to give our data to to ChatGPT, the public cloud version. We want to have this in-house. What would that look like? How would that manifest?
So we need to have our inbuilt modeling built for it, because it will also be customized for our use case, right? Mm-hmm. We don't want it to return like something which is out of the context, right? And not maybe good for the general context, but not in the LinkedIn context. So I want everything to be in-house. So every the various information that I'm capturing in LinkedIn from my from user activities, everything, like all of that will reside in my local in-house large language models. And it's like I'm storing all that data store, training my model on it, and also taking in the feedback again and again. For example, I'm doing returning some results. Is the user finding it relevant or not? Are they? Okay. I may not need to ask them directly whether you're finding it relevant or not. I can also use their signals. For example, if they're clicking and going and applying for a job, probably they are finding it relevant. If they are not doing so, have not taken any actions, it's not relevant for them. There could be further chance of improving it. So I'll capture all this data and put it back in my feedback loop. So it will be something that we have to develop in the context of LinkedIn and in-house is something I'm thinking.
Okay. As you dive deeper into your system design, it's a good idea to clarify what the components are responsible for. Shivali did this by stepping through an API flow touching on the various components, and also adjusting to the interviewer's direction. Okay. Tell me a little bit about, you mentioned early on one of the sort of non-functional requirements that, you brought up and we sort of agreed on was latency and performance. So talk to me a little bit about that.
Yeah, it's correct. So, I mean, we want these results to be returned pretty quick, right? I mean, the user, no one wants to wait simply. So there are a lot of optimizations possible here. For example, the user profile, right? The user profile database is an information which is not going to change very often. Like after a certain time, only the user is going to come back and maybe update and add new stuff to that. So definitely it's beneficial to have a cache layer over here. So I'll just make maybe a simple layer, which is like a cache layer. So this way, my results can be returned pretty quickly from my data store. The another thing for relevant to the user profile, there is also a scope of building a cache over my Elasticsearch. So that way, for example, there are very common keywords being searched, right? Let's say like today, now we're thinking like it's a AI generation, right? So probably everyone is searching for, a lot of people would be searching for the AI related job. So this is a very common keyword being searched. So why not cache such things and to avoid overload on our Elasticsearch in such cases. So I would like to cache some hot keywords alongside their common results from my Elasticsearch, while they can still be ranked basis whatever the user personalization is. So hence, we can also have a cache for primarily the hot keywords over our active job data Elasticsearch. So that will also help us save some time and eventually improve our latency. The another thing I'm also thinking is like, these things we can do in terms of optimizing the latency. Now, in terms of the performance and making it fault tolerant and also highly available, the things that I would like to do is making sure first is that these systems have for example, our job data search, the user profile, everything has a replica so that the data which user is storing with us is not lost. So that is one thing. Also, I would like to make it available in different regions so that even if one availability zone fail, I don't want it to, just go away. So probably separating that out also helps. And also, LinkedIn is a global service. So as if we have to also handle for different geographies, they will have different scales. It's better that we separate out their data. And also they may have a different policies. For example, the GDPR in the EU region, they want the data to be localized versus all those things. So bringing in that compliance angle as well, I want to keep that data separately also in their in-house data stores or somewhere else, which is whichever is needed for that region. So that way, also the impact will not be there across geographies. So that is there for the performance. The another thing is even in terms of the ranking service, right? Let's say in case of some issues, let's say the personalization service is not able to actually personalize the data. So one option is, of course, I keep on waiting on that and do nothing, right? It failed the request, not able to show the relevant results, which is not, of course, a good user experience. In that cases, I may want to just default back to the common, to the simpler logic, which I called out earlier. For example, the rank it by the latest job date, maybe. So very simpler logics. So I'll also I want to put in these levers into my system. Like, what if this fails? I can do this kind of a system. So I think these come top of mind.
Okay, that all sounds good. Can you talk to me a little bit about sizing here? So, for example, the two caches you've described, how would you size these?
Okay, great. So the user profiles database, right? So for example, we're talking about 100 million daily active users, right? So they are. We'll have a huge number of users, but then 100 million are our daily active users, which means we'll be querying them time by time, right? And if I have to size that in maybe our kind of a thing, I would probably keep it smaller, because I also want to refresh my cache at a certain interval, and this cache refresh maybe after every 15 minutes or 30 minutes. So for that, if I have to take a size of it, like, because for a 15-minute data, I want to keep in the users who are searching that now. So it may be like the size would roughly be around some maybe even taking a buffer of it, like not it can be like 50% of it, like 50 million users data probably I want to store in that data store. Yeah. So that's what I think about the user profile.
Okay, so get more specific for me. Talk about bytes here. How big is this cache?
Okay. So the user data, right? So let's say for a user, so the information that we are storing, so it should not go beyond. So it's more like a textual information in terms of what is their location, etc., etc. I'm keeping the so the information that I want to cache is the key things about a user, not like everything. For example, profile image. There is no point in caching all that information. So in that case, that data which I want to cache will not go beyond. I would say maybe 1 KB in size. It should not go beyond that. It's simple textual information. So I'll try to keep it like so it's 1 KB multiplied by some 50 million users. So it's 15 million. So let me just think of do that maths. So 50 million, and that's KB. So it's going to be MB. So it's roughly, I think, 50 GBs. Is if my maths is not wrong. Yeah.
Okay.
Yeah. Yeah.
Okay. So you've got a 50 gigabyte cache for the profile. What about the active jobs?
Yeah. So the active jobs, if I see, right, so it's like a 20 million jobs that we have in this, which are like, let's say the active jobs, which are, oh no, I think I took an estimate of 10 million jobs. So now these 10 million jobs will have, now let's talk about this, right? Here I may want to store a lot of attributes about it, but then again, this data also would not be huge, but like, let's say it's even because there could be a lot of tags associated with jobs and a lot more information. So this data will be a bit bigger in size. So let's say it's like maybe 10 KBs of data for each job. So then also it would be so 10 million. So it's like, I think 100 GBs of cache, right?
Gotcha.
So
gotcha.
Yeah,
okay.
That's what I think.
When you're refining your design, it's important to focus on the things that matter. Which components or aspects would benefit the most from availability or performance improvements? Shivali did a really nice job of looking at those data stores which would benefit from caching, different technologies such as Elasticsearch and replication, as well as compliance aspects such as GDPR, which are really important in a global distributed system. Of course, also as part of this refinement, an interviewer may ask you about sizing, so you should be ready to respond with details and maybe even do some math. Like what might be an approach where you simplify your architecture and rely more heavily on AI? What would that look like?
Okay, so in that case, it would be something like, so essentially anything that I want to search, shall I try to draw that? I think it will be better.
Sure.
So let me say, so it would be something like a simple architecture where, I continue to have an API gateway, but then, so I think we talked about 2 integrations right here. One integration could be through a chatbot solution that I proposed, or the other could be just like let's say this is a AI engine that I have, my black box system. So anything that I'm entering from my server. So one option is like, this is my, so there could be actually various integrations. So one is my search job service, which is actually what it's doing is it's actually just converting the user input and maybe taking in the user profile, and for a user ID, it's just calling that directly. So it's like this. And similarly, we can have like let's say I have another thing could be the thing that I've exposed to the user could be my chatbot assistant, which is again whatever convert thing that I'm passing to it. It's let me just see. So it's converting it back to calling the AI engine again and returning back the results. So this is how I'm thinking. What do you think about it?
Yeah, that makes sense. I think so. I think what you're what you're describing, if I understand it correctly, is one option that is more maybe parameterized, if you will, more in the classic sense, and the other one is more like I'm talking to ChatGPT as a job seeker, right?
Exactly.
Okay. Let me ask you, throw one more thing at you here and see how you might think about this. What if I wanted to have sort of not exactly what the right term is. I'm feeling lucky, the Google equivalent of I'm feeling lucky back in the day when, you just, the first search result is where it took you. You just, said I'm feeling lucky and just took you the first search result. And I'd like to sort of have a similar thing where I'm going to rely completely, or I would like to be able to rely completely on your service, which is AI backed, to apply to the top 10 jobs that you think are relevant based on everything. What would that look like? Talk to me about that. There being so instead of a job search API that gives me back results, I'm too lazy for that. I just want you to do it. I trust you. Go ahead. You know everything about me. You know all of my activity on LinkedIn. You know all of the jobs. Just I'm feeling lucky. Apply the top 10 jobs that are the closest ones to me. That match based on what you know about me. What would that look like?
So so I think in that case, how it would look like is like you are not giving me any parameters, right? So what I'm doing is there's another, so at a user level, let's say, right? So I have, I think that information about user details or user profile can also be like simply fed into the AI, where it's also decorating, essentially it's also having a lot of information about a user. And so it would be then very simple. Like what I'm asking it is, for this user, tell me what are the relevant jobs. So it's very simple as that. So on the chatbot assistant, let's say you just type in that, okay, find me relevant jobs. Nothing more, nothing else that you're saying or asking it, right? So it's just taking in your user ID, querying, like all the stuff is being managed by AI. So the AI is actually having your information about who you are, where you belong to, your activities, everything. So it's the system will, in some sense, down the line, will become intelligent enough to like decorate and handle this large amount of data, and provide you the relevant results.
Great. If the interviewer asks you to go beyond the stated problem and think bigger, here's your chance to show your creativity. Shivali started from scratch with her diagram and stayed at a high level talking about AI as a technology and how to integrate rather than getting into the details. This is a great way to show some quick brainstorming. All right. Well, thanks everyone for watching this mock system design video, and stay tuned for hopefully more. And if you enjoyed it, give it a thumbs up.
Hello, I really hope you found that useful. If you did, you can like and subscribe, and why not come visit us at IGotAnOffer.com. There you can find more videos, useful frameworks and question guides, all completely free. And you can also book expert feedback one-to-one with our coaches from Google, Meta, Amazon, etc. Thank you and good luck with your interview.